In this demo, we'll look at an example that uses the API key authentication model. This is the most basic form of authentication and is used to identify an application when all of the API's functionality does not involve the end user. We can think of this as a password model. The API key serves two purposes, both identifying the application as well as authenticating it. Sometimes, additional parameters like user agent are used to identify the application, but the API key model does not have any standards requiring this. API keys in general are long strings representing passwords given to developers when they first register a developer account. Since API key authentication is not a protocol but a model, the implementation details are left to the developer. The API key model is used in many read-only applications that fetch globally accessible data. Typically, API key is only used to keep track of an application's usage of a resource and rate limit them should an application be going over a specified limit. Public APIs can be queried without limitation and are often targets for denial of service attacks. An API key authentication model limits the effectiveness of these attacks as each key identifies the rogue application. API key authentication has no mechanisms to handle user permissions, however. If we need to fetch user-specific data, for example, a user's custom playlist when using the Spotify API, we need to use a different model, as API key does not have trust mechanisms that other models, like three-legged OAuth, provide. This may not seem like a big concern. Who cares if someone has access to my personal playlists? But the same techniques are used when granting applications access to your personal email, for example, to discover contacts, or a social media account to post on your behalf. You only want applications to be able to do this if you have explicitly granted them permission. Now that we understand what API keys can't do, we can look into how they work. Typically, the first step is to register our application with the API's developer websites and collect the API keys necessary to authenticate with them. For the usajobs.gov website, we'll navigate to the developer portal and fill out a form requesting an API key. Once we get an API key, the next step is to follow the documentation to simulate a request and attempt to interact with the API using an HTTP debugger like Insomnia or Postman. This typically involves setting the header, query, and post data fields as outlined by the documentation. As API key authentication is a model and not a protocol, the structure of the requests will differ across various implementations, and you'll need to go through the documentation for each API you want to interact with. In the usajobs.gov example, authentication involves adding the following values: host, user agent, and authorization key to the header of each request. The host specifies the resource being requested. This value will always be data.usajobs.gov. The user agent tells USAJobs who is originating the requests. This value should be the email address used when registering for an API key. The authorization key will be used to determine what type of access you have. This value should be the API key you were provided after registration. Once this has been added to our headers, we can query any of the API endpoints listed under the documentation. This API has 14 endpoints, but we're only interested in the get/API/search endpoint. This endpoint accepts various query parameters to filter a job search by. It is far more extensive than the GitHub Jobs API. But for our demo, we will only use the parameters keyword and location name, as my goal in this demo is to create roughly the same application as the GitHub Jobs project using a different data source. Inside of Insomnia, we create a new request. Since I'm trying to access the search endpoint, I set the endpoint to get and the URI to be the search endpoint. In the request headers, I include host, user agent, and authorization key as required by the documentation. Generate your own values, as the ones supplied here are placeholder values and will not work. It's a good habit to safeguard your API credentials. There are numerous horror stories on the web of keys for SaaS products like Amazon Cloud accidentally being leaked and costing the developer thousands of dollars in API usage. Anyone with your API key can effectively act on behalf of your app. In the Query Parameters tab, I include keyword and location name properties with values Java and New York. We can click Send to generate and send the HTTP request to the server. Because the headers I supplied were dummy values and not valid, I received back a 401 status code, unauthorized. HTTP debugger tools like Insomnia work by allowing developers to focus solely on generating the necessary HTTP requests to facilitate their application without needing to mix in code and needing to worry about syntax and side effects as well. Once the HTTP request is debugged, we can mechanically transform that request into code. Next, let's look at an example of a successful request. When supplied valid credentials, we should get back a 200 OK response with a large JSON object containing the search results. If you are getting a 401 unauthorized, review your query parameters and header values and try again. Next, we will navigate the JSON object. This is just a complex object containing primitives, arrays, and other nested objects. Typically, I navigate this by working top-down in Insomnia, collapsing and reversing the collapse of each property until I find the property that I'm interested in. Since we are trying to replicate the previous example, we need 3 elements: job title, job description, and URL. Starting from line 1, I will collapse the results and then expand them again, working through each property, making note of the path that I need to take to find the values that I want. Assuming the parsed HTTP response received is called job object, the first property is search results. We can access it by using jobObject.searchResults. Continuing our way down, collapsing and re-expanding, the next object is search results items. We can access it using jobObject.searchResults.searchResultsItems. The contents of this property is an array, so we'll need to loop through each result. Each represents a job matching our search criteria. We can access each result using jobObject.searchResults.searchResultItems square brace I. In this example, we have 3 search result items, but you may have more or less depending on how many jobs are available. For each search result item, there are 3 properties, but we only care about the matched object descriptor property. We can access it using jobObject.searchResults.searchResultItems square brace I matched object descriptor. Finally, inside of this object, we have the 3 properties that we want: position title, qualification summary, and position URI. Our code will need to make the exact same traversal of the JSON response using object and array accessor notation, dot and square brace notation. The first major change occurs on line 6 with the inclusion of a credentials file. This is where I store the host, user agent, and authorization key properties, so that they are not embedded inside of the code. If you're using a version control software, ensure that this file is not uploaded by setting up a gitignore file. Open up this file and fill in the missing information. The data should be in JSON object format and match the values in the Insomnia header component. Notice the double quotes on the keys and values. This is required by the JSON specification and also allows us to use dashes in the keys. You should always test any code that you manually type in with a JSON validator. I'm using jsonlint.com here. Our request handler function is the same as before. The getJobsInformation function has been changed substantially. Some of these changes were made to illustrate that there are multiple ways to solve a given problem. The jobs endpoint variable now points to the usajobs.gov site. The endpoint should match the URL preview inside Insomnia. Another major change chose to use https.get instead of https.request. https.get is slightly more convenient if you're working with GET requests. The documentation states, since most requests are GET requests without bodies, Node.js provides this convenient method. The only difference between this method and http.request is that it sets the method to GET and calls requests that end automatically. Headers are required for this example in order to get authentication working. These get placed into the second parameter of https.get. The second parameter is the options object used to customize our requests. Method is actually not required, as the method defaults to get, but it helps to illustrate what the options parameter is. The headers are set to be the contents of the credentials.json file. https.get will send the request out without the need to call a end method. This example uses event listeners to wait for a response, in contrast to the first example where we use the third callback parameter. The emitted events will include a stream object, job stream. From here we process the receive stream one chunk at a time, and pass the combined response, called jobs data, to the function serveResults. serveResults parses the data and begins the traversal step that we simulated earlier. To get the values that we need to be able to access the matched To get the values that we need to be able to access the matched object descriptor for each search result. The URL job format again is job object.searchResults.searchResultItems, which is an array, so we need to loop through each element from 0 to n-1. Each search result should have a matched object descriptor, which will have the three properties that we want: position title, qualification summary, and position URI. After parsing the results using JSON to parse, we can start the navigation process. This code contains a pattern called the optional chaining pattern, which is very common when consuming data from an API that supplies its resources via JSON. JSON has no schema or required structure. This can cause problems if some members don't fit the exact structure. It's possible that one or more of the properties for individual jobs may not exist. This can cause the entire chain to fall apart because of a null pointer exception. For example, in the results that we received, we had 3 jobs. If for any reason matched object descriptor did not exist for one of the jobs, the subsequent call to matched object descriptor.positionTitle would crash the server because of a null pointer exception. You do not want your program to break because of a missing property. The optional chaining pattern uses a feature or quirk of the JavaScript language. In the language specifications, undefined and anything results in undefined, skipping the evaluation of anything. When some object property chain becomes undefined in some node, the rest of the expression is short-circuited and not evaluated. Since the evaluation step is skipped, the error will not be created. In our example, we have job objects, $, job object.searchResults, $, job object.searchResults.searchResultItems. If job objects, for some reason, became undefined, anything after it is not evaluated, and undefined is immediately returned. This mechanism provides a safety that makes the code a bit more verbose to read. Node.js 14 adds official support for the optional chaining operator, which is question dot. This addresses the long chain of double ampersands that was previously required for safety. We loop through each search result items by using the map function. Each job gets passed to the function formatJob. Inside of formatJob, we continue using optional chaining until we can get the position title, qualification summary, and position URI. With these 3 values, we can format it using some simple HTML, and then send it to the user using res.end. Let's run this code. If I put in Java and New York, I will see the same 3 jobs that we got via Insomnia. The next example has us combining the 2 job APIs to perform searches in parallel.